folks, Ms. Gosling here. In this video, we will be discussing the vocabulary we'll be using in our electrostatics unit. Now before I go on, I want to acknowledge the fact that many people find vocabulary rather dull to learn. I also feel this way. However, it's vital that you learn all of this because having a common vocabulary is necessary for clear communication in science, or really in any field. So by the end of this video, you will know the definitions and the units for the key vocabulary in Unit 1. I will also be differentiating between our fundamental vocabulary, which is the vocabulary that you need to know to understand anything in this unit, and the useful vocabulary, which, while useful to know, if you are struggling to learn all of these new terms, are things that you maybe can leave off until later. So the first vocabulary word that we're going to talk about is charge. As you can see, I have written charge in red because it is a fundamental vocabulary word. That is to say, you need to know what charge is to understand the rest of this unit. So charge is a basic property of matter, and it causes electric forces. Now your charge can be positive. An example of a positive charge is a proton. It can be negative, for example, an electron. Or an object can be neutrally charged, for example, you. And if an object is neutrally charged, we'll say that its charge is 0. The units we're going to use to measure charge is the coulomb, which we represent with a capital C. Our next vocabulary word is electric force. And an electric force is going to be the force of attraction or repulsion between electric charges. And the thing that's really interesting here that's different between electric forces and gravitational forces is that an electric force can be attractive, like gravity, or it can be repulsive. So two charges can be pushed away from each other instead of towards one another. And our units for electric force are newtons, like they are for any other force. And as always, we represent newtons with a capital N. Our next vocabulary word is electric field. And an electric field is a region around a charged object within which it can exert a force on other charged objects. And we're going to measure our electric field in newtons per coulomb. Next we have current, which is the continuous flow of electric charges through a material. And current is going to be a rate of charge. So we're going to measure our current in amperes. And what's really nice about this unit is that this is a fundamental unit. So as you remember, we talked about fundamental and derived units at the beginning of the year. Current is one of our items that is measured in a fundamental unit rather than a derived unit. So our next vocabulary word is drift speed. And the drift speed is going to be the speed at which ions, so that is to say charges of some kind, move in a conductor. So these ions are only going to move in a material that can conduct them, that allows them to move. And we're caring about their speed. So as always, we're going to measure our speed in meters per second. So that is going to be our units for drift speed. Next, we have potential difference. Potential difference is going to be the work that is done when one unit of charge moves between 2 points. So if our charge is moving from point A to point B, we can find the potential difference between those points by figuring out how much work is required to move our charge from A to B. And we are going to be introducing a new unit for potential difference, and that is going to be the volt, which we represent using a capital V. Next we have the electromotive force, which is the transfer of energy to electrons from other elements in a circuit. And this term is actually really a bit of a misnomer because the electromotive force is not a force. And in fact, we are going to measure it in the same units that we use to measure the potential difference. That is, we will use volts. So next we have the electron volt. And the electron volt is actually a new unit, so we're not going to have any units for it. And we define an electron volt as the amount of energy gained by an electron when it moves through a potential difference of 1 volt. And we are going to say that 1 electron volt is equal to 1.6 times 10 to the negative 19th joules. Okay, so we've made it through all of our fundamental vocabulary, and the rest of this video is going to be about some of our other vocabulary words that, again, are useful but not necessarily fundamental to understanding the unit. So the first of those words is conservation of charge. And this is one of our conservation laws, and what it states is that in a closed system, so no charge coming in, no charge coming out, the amount of charge is constant. So next we have the elementary charge, which is kind of one of the basic units of charge, and it is going to be the charge on an electron, which is negative 1.6 times 10 to the negative 19th coulombs. So you may see in a problem that you have, instead of giving you a charge in coulombs, so for example, instead of saying you have a charge of 10 coulombs, you might see instead that the charge is equal to 10 E, which is 10 times that elementary charge, so 10 times negative 1.6 times 10 to the negative 19th coulombs. So next we have a thing called a conductor. And a conductor is going to be a material that conducts electricity. Most conductors are metals. However, some ions in water, so an aqueous ionic solution, might also be a good conductor. However, most solid conductors are metals. So next we have insulators, which are the exact opposite of conductors. So an insulator is a material that does not conduct electricity. So, for example, rubber or dirt or wood. All of these are insulators because electricity cannot travel through them very well. Okay, so next we have electric breakdown. So when an electric field is strong enough to create ions in a gas or liquid, we call that process electric breakdown. So what's happening is instead of just the electric field existing, what it's doing is it is in fact ionizing atoms, and usually will create some sort of really cool light show. So lightning is one good example of electric breakdown, as are neon lights. Okay, so you've made it through all of the vocabulary. So some key takeaways. Electricity is about the way in which charges interact with one another, which you hopefully saw through all of the focus on charges that we had throughout this entire video. And then finally, there are a lot of vocabulary words that are useful to use when describing electrostatic interactions. Thank you guys for watching. Now it's on to the next video.